So 7.5 is all about solving exponential and logarithmic equations, right? Not just trying to figure out what they equal, but now using them to solve for x. And so how do we solve these equations? So I'm going to give you 3 strategies for a total of 4 examples. So as I'm going through these, please make sure just write down the example and then maybe write down some key things I say, and I'll try and make sure, I'll try and make sure that some of those get recorded also. Strategy 1. The first thing you can do for an exponential equation is make both equations have the same base. Okay, so if I'm looking at this equation, I can make it so those both have the same base. Why can I do that? 27 equals 3 to the third. So this 27 I can replace with a 3 to the third. So now I have 3 to the third x equals 3x plus 8. Now on that left side, it might make sense to use those rules for exponents and clean that up a little bit. When we raise something and then raise it to a power, if we have a power to a power, an exponent to another exponent, then we have 3 to the 3x equals 3x plus 8. When the bases are the same, so I got a 3 here, I got a 3 here. When those bases are the same, the exponents are equal. So the bases are the same. The exponents are equal. So that means that 3x here equals x plus 8, because if the bases are the same, the exponents are equal. From here, you could totally solve this. 2x equals 8, x equals 4. From here down, it's not so tough. From there down, it's not so bad. It's how do we get there? And in this case, our strategy that we used was to see if we can make both equations have the same base. If you can do that, that's a good strategy to use. So write this one down, write down the hints that I wrote down, like, oh my gosh, I could see that 27 was 3 to the third. And so once the bases were the same, the exponents were equal, and so then I could make an equation out of that. Okay, so get that written down. What happens if you can't make both bases the same? That's where we're going to take us to strategy 2. And what we're going to do is we're going to use the log. Okay, I'm going to show you an example. 7x to the third equals 350. I cannot take 350 and write it as an exponent with base 7. 350 does not work nicely as an exponent with base 7. So I have to use the log of both sides. So I'm going to take the log of this side and the log of this side. So I'm going to take log base 7, log base 10, right? So log base 10 of 7x minus 3, or raised to the x minus 3, and that's going to equal the log of 350. Now, by the power rule, the powers of logs rule, this x minus 3 can be brought to the front. So I'm just using the power rule to get me to here. So I've used the power rule to pull x minus 3 to the front. Okay. Then I'm going to divide by log 7 on both sides. Divide by the log of 7 on both sides. Here it'll cancel. And I'm at x minus 3 equals. So I go to my calculator, I do the log of 350, and I divide it by the log of 7. So log 350 divided by log of 7. And that gives me 3.01. Now to get x by itself, I add 3 to both sides, and I'm at 6.01. Okay. It all started because I took the log of both sides, right? It's like adding 4 to both sides or square rooting both sides. I'm taking the log of both sides. Log of both sides, then I had to apply the power rule, and then worked from there. Okay, so this is another way to solve this equation. 7 to what power makes 350? Well, 7 raised to 6.01 minus 3, so 3.01 equals 350. Get that one written? Now, if we go back and think, both of those equations started as exponential equations, which means we had exponents. Now I want to show you a strategy for working with logarithmic equations, or equations that start with the log in them. Okay, so let's look at 2 examples here. Basically, we're going to rely on the definition of a log. So let's look at solving this one. Log base 4 of x minus 1 equals 3. I have no idea what would go there. But what I do know is I know how to maneuver between a log and an exponent. And from looking at your quizzes, so do you. We have a base. We have what we're taking the log of. And we have our exponent. So, 4 to the third equals x minus 1. 4 to the third equals x minus 1. That really is what that log is saying to us. So then, 64, because we all know that 4 to the third is 64, well, that equals x minus 1. That means x equals 65. That became really easy to solve once we knew the definition of a logarithm. And I'm just going to refresh your memory. Log base b of x equals a is the same as b to the a equals x. We've talked about that. The b's are always the base, and the answer is the exponent. The logarithm tells us or helps us find the exponent. The logarithm helps us find the exponent. So the answer here, the answer to the log, is the exponent. Okay? So just by using the definition of a logarithm, we were able to make this happen. Okay, so get this one written down. Think about how this helps us. Think about what we did from this step to this step. After that, it was just easy peasy solving. I hope it was easy for you from there. If you could do this, your whole solving is going to be a lot easier. So the last strategy I want to show you is called strategy 3+. And why is it called 3+? Because it's the third strategy, which was throwback, use the definition. But now we're going to use some properties so that we can actually do the definition. Here's what I mean. Let me clarify this a little bit for you. Let's look at an example. Log of 30x minus the log of 6 equals 4. I know how to use the definition of a logarithm. I know how to work with the base. I know how to work with what the exponent is. I know how to work with that. But I have no idea how to work with it when I see 2 logs in the same problem. So what am I going to do? I'm going to start with the quotient rule. The quotient rule for logs. When I see this subtraction here, what? Okay. When I see that, that tells me to divide. So I think now log of 30x over 6 equals 4. So that really means the log of 5x equals 4. Okay, so now I think, how can I use the definition of what a logarithm is? Well, the base here is 10. When we don't see a base, we think 10. So 10 to the fourth, because the answer to the log is the exponent. Logs help us find the exponent. 10 to the fourth equals 5x now. 10 to the fourth, that's a 1 followed by 4 zeros. That is 10,000, wonderful people. Equals 5x. X then equals 2,000. Ta-da. So yes, we use the quotient rule, but then we followed it up with the definition of logarithms. Or how they work, right? We followed it up with how to change between a log and an exponent. We just flip the 10, the 4, and then the 5x. The base of the logarithm is the base of the exponent. The answer of the logarithm is the exponent, and then that 5x is just chilling. Then it became easy to solve, and all of them, once we got past what was happening with logs, they got easier to solve. So here's 4 examples. Okay, I want you to be able to do these, or to be able to at least have an idea of how to get started. So when you come to class tomorrow, you're ready to rock, okay? Thank you, thank you.